Okay, in this lecture, we're going to go over the first question on the practice exam. Originally, I had a different question, and so the video that was posted may have been over a different question, but this is over the question that is on the practice exam. So I'm going to go ahead and do that, and so I'm going to share my screen. And so we've got the practice exam on the left-hand side. I'll just go ahead and maximize this. Okay, go ahead and download the data set, and when you download the data set, it will look like this. And so, yeah. So the president would like to know how the average number of confirmed cases in North American countries compares to the average number of confirmed cases by country in the world. Below is the information for confirmed cases in North American countries, um, and the average by the world. With a chance of type 1 error of 5%, do North American countries have a different number of cases compared to other countries? First of all, what is the dependent variable? Well, let's go ahead and look at our data. So we've got North American country cases in North American countries, and then we've got the average number of cases in the country by the world. They also have the world standard deviation, which oddly enough is greater than the actual average. So the president would like to know what is the dependent variable? So the dependent variable um, is going to be these values right here. So it's the number of cases. So the dependent variable is, okay, we're looking at the number of cases. And the independent variable is what are these number of cases dependent on? It's dependent on location, whether it's the world or just North America. And so we're going to put location. So what are you examining or comparing? This is what's the purpose of each of these tests? This test right here, we are looking at the mean of a single sample compared to a population mean. And so we are looking at the, let's see here, the observed frequency, no, the mean of a sample and the mean of a population. Okay. And then what is the tail of the test? So let's look at this. The president would like to know the average number of confirmed cases in North American countries. What's the tail? If they have a different number of cases compared to all countries. So this right here is a two-tail test. Okay. What type of test are you conducting? Well, let's go ahead and look at this sheet right here. Actually, that's not what we're going to look at. We're going to look at File, Open, let's see here. Dun, 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 dun. We've got this. Let's just look up final project example. Here we go. So we're going to look at our decision tree. Let's go ahead and look at our decision tree. And so are we looking at continuous data or are we looking at frequencies of categorical data? And the answer is we are looking at, well, this is a little bit different. We are actually looking at the average number of cases. And because we're looking at an average, it is actually continuous, even though it kind of looks like it is because it looks like it is discrete because we're looking at the number of cases in each country, but we're looking at the average number of cases. And so because of that, it makes it so that we are looking at an average compared to an average, which means that you don't necessarily have meaningful gaps between them. And so you are actually looking at continuous data. And so we're looking at continuous data right here. Because we're comparing an average to an average. And so are you examining the average of a sample compared to a population? Or are you examining the difference between groups? Sorry. And what we're doing is we're examining the difference between a sample and a population. And so we're going to do a single sample test. And so let's go ahead and put this right over here. And we'll put this on the other side. And so we're going to do a single sample test. So the null and alternative hypothesis. So the null hypothesis and the alternative, well, it's a two-tailed test and it's a single tail, or it's a single sample test. So we are looking for, first of all, this right here is a single sample because it's a sample mean compared to a population or a value. This right here is a sample mean compared to a value. and then this down here is a sample mean compared to a value. And so now it's one of these three, and this is a two-tailed test, so it's going to be right there. And so I'm going to look at this. Yep, we've got the average. So it's 62,877. So the answer is the mean of the sample is equal to 62,877, or it's not equal to 62,877 because it's a two-tailed test. What's the level of significance coming right up here? 5%, 0.05. Test statistic, because we have the population standard deviation, it's going to be a z-score. Then what are the critical values? Well, that's a great question. In order to calculate the critical values, there's a really good resource for you to determine what the critical values are. Let's go to single reference, and it comes right here. What are the critical values? Okay, and so we look at this using a z-test. Well, there's actually two things you can look at, but this is a two-tailed test, and so for the critical value, we are going to do equals norm dot s dot inverse, and then 0.05. Let's do 0.05. Actually, so 0.05, and so this right here is for a one tail, but for a two tail, what we're going to do is 1 minus the probability. So let's do this. Norm.s.inverse. And so you've got the probability plus 1 minus 0.05 divided by 2. See what that does? It does not like it. It does not like it at all, Sam I am. And so I think that this is 1 minus the probability divided by 2. Yeah, this seems to be a little off. So let's just do this. 1 minus 0.05 divided by 2, or 0.05, it really should be 0.05 divided by 2 here. Let's do this. So this right here, I really should change this to alpha divided by 2. Okay, so alpha value divided by 2 is what you need to do here. And so let's just go ahead and do this. Alpha value divided by 2. And so that gives you the negative, and you need to put both the negative and positive. And so it's negative 1.96 and positive 1.96. And so we've got this right here. What is the critical values? Plus or minus 1.96. Okay. What is the calculated value of the test statistic? So the calculated value of the test statistic, let's take a look at this. What is the calculated value of the test statistic? Well, in order to do this, we need to get the sampling error and the standard error. Okay, so let's do this. We're going to data analysis. And so we're going to do descriptive statistics. And then we're going to do an output range, put right here. Whoops, I forgot to do this. And I thought I did that. Okay. So we've got the mean, standard deviation, so on and so forth. And so first thing that we're going to do is sampling error. The sampling error is going to be equals the sample mean minus the population mean. And then the standard error is going to be equals the population standard deviation divided by the square root of the sample size, which is 37. And so we've got the standard error and the sampling error. And so we're going to do equals sampling error divided by standard error. And that gives us our z calc. So z calc is negative 2.296. So let's go ahead and take a look at this. Actually, so negative 2.297. If you actually look at 2.2969, so negative 2.297 is the z value because I took the sampling error divided by the standard error. Then what's the probability of observing a sample as extreme as or more extreme than the value? In order to do that, you need to calculate the p-value. So the probability, and so what is the probability? So this right here is a two-tailed test, so it's going to be 2 multiplied by norm.s.dist, and then you put the z value and cumulative. So let's go ahead and do this. So what is the probability? And that's a two-tail probability, so we're going to do equals 2 multiplied by norm.s.dist, and then the z value, true. Okay, and this is very specifically for a lower tail test. If it was for an upper tail test, you would do 1 minus the z value, or you do the negative z value. And so the probability of getting this is 0.02. And so we're going to do 0.0216 right down there. Okay. And so because the probability is less than the alpha of 0.05, we are going to reject the null hypothesis. So let's look at this. Reject the null hypothesis because the calculated test statistic is more extreme than the critical value. This is the correct answer right here. This is not, because we're not failing to reject, and the null hypothesis has been proven to be true. That's not correct either. The alternative hypothesis, we're not proving anything to be true. We're saying we reject or we fail to reject. So reject the null hypothesis. What's the effect size? Well, that's a great question. What if I had a really great resource that told me how to calculate the effect size? The effect size, you take the right here, m minus mu, okay, divided by the standard deviation. Okay, so what we're doing is essentially taking the standard error divided by the standard deviation, or sorry, the sampling error divided by the standard deviation equals sampling error divided by the standard deviation, and make sure that you do the absolute value. And so that gives us an effect size of 0.37. So 0.3776. And then what would you say about what can be interpreted? So there's 3 things down here. The difference of ... negative 30 ... between the USA and the average of all countries is too large to have occurred by chance, or rather, between North America and the average of all countries is too large to have occurred by chance. The difference is somewhat noticeable. The president should know that the North America has significantly more cases than the average country. The difference of this, which first of all, that's not the difference, is not large enough. So that's not true. The president should collect more information. And then there's not enough information. So this is the only correct one. And so we are going to put 1. And this right here is a small to medium effect size. And you'll notice right here, 0.2 to 0.5. And so this right here is in the middle of there. So it's a small to medium effect size, which means that it's somewhat noticeable, but not super noticeable. So yeah. So that's question 1, and that's pretty much it.